Hi, I'm Chad with Mastercam. Sometimes standard drill cycles don't give us enough flexibility for all the holes we need to create in a part. As you can see, these 4 holes in our Formula SAE Upright pass through multiple layers. There are 2 layers of material with a layer of open air in between. One of the key enhancements in Mastercam 2021 allows us to apply different parameters to each layer of material in multi-layered holes like these. Let's take a look. First, let's program a drill operation with existing tools. Open a drill toolpath and select the solid face representing the hole feature. The normal must face in the direction of the open air. We'll be using tool 14 for the larger holes, so let's set spindle speed to 1500 RPM and the feed rate to 10 inches per minute. On the cut parameters page, select the peck drill cycle and set the peck distance to 50 thousandths of an inch. On the linking parameters page, we'll activate calculate depth from top of hole. Next, right-click in the depth field and choose distance between 2 points. Use the 2 points to measure the depth of the hole across all layers. It's important to make sure that 3D mode is active before making the measurement. We also need to make sure to change the measured depth to a negative number. To save cycle time, we'll set a lower retract value as well. I'll use 50 thousandths of an inch for this example. To ensure the drill tip passes completely through the bottom layer, we'll also activate tip comp and apply a breakthrough of 50 thousandths of an inch. To simulate this drilling motion, let's open Verify. Note how much time is wasted with the drill pecking in open air. It would be far more efficient for the drill to plunge to the beginning of the second layer of material. If we look at the toolpath info on the right side of the screen, we see that it took 28.68 seconds for this path to run, with the drill point traveling 37.86 inches. Now let's use some new tools to make this operation more efficient. Open the toolpath parameters and change the toolpath type to Advanced Drill. Everything on the tool page remains unchanged since we're still using tool 14. You may notice that the linking parameters are now missing the depth option. The tip comp page is also gone. That's because all those controls are now inside the interface on the cut parameters page. To make this toolpath identical to the old drill toolpath we made, deactivate the clearance field and set the retract height to 50 thousandths of an inch. Top of stock will remain at 0. The Advanced Drill toolpath allows us to create a segmented drill toolpath with unique feeds, speeds, pecks, spindle directions, coolant commands, and comments for each segment. We can advance the drill in positive or negative depth directions at any point in the toolpath. All this power is controlled by the new interface on the cut parameters page. The table in the middle of the cut parameters page is where we'll enter our segment parameters. The image on the right of the page shows a visual representation of the segments. The ability to control segments makes Advanced Drill a great option for deep hole drilling. We can program a drill to enter a hole at a very low RPM and increase the RPM as the drill becomes engaged. Or, more relevant to our FSAE Upright, segment controls make Advanced Drill the perfect option for drilling through air segments more efficiently. Let's right-click in the depth field for segment 1. We need to enter the thickness of the first segment as a negative number, so we'll select length of an entity and measure this line. We'll change the value to negative 0.25 inches and for consistency, set the feed rate of this segment to 10 inches per minute. The spindle will be running clockwise at 1500 RPM. Let's turn on flood coolant also. Right-click on Retract and select Insert Segment. Now we need to find the distance from the top of the first segment to the top of the second segment. Right-click in the depth field and choose Distance between 2 points. Measure the distance between the tops of the 2 segments. Again, this needs to be negative, so change the value to negative 0.909 inches. This is the segment where the drill will be in open air, so we can increase the feed and lower the spindle RPM. let's set the feed rate to 500 inches per minute and change the RPM to 2000. We'll turn off flood coolant as well. For the final segment, let's repeat the process. Again, right-click on Retract and select Insert Segment. This time, our distance between 2 points will be the full depth of the hole, and again, we'll make the value negative. Now we can switch back to our normal parameters of 10 inches per minute, 1500 RPM at the spindle, and flood coolant on. For the retract segment, let's change the feed rate to 500 inches per minute and turn the spindle off to prevent the drill from spinning in open air. We can also turn the coolant off. Notice how the segments are displayed on the right. When you hover over the segments, the corresponding segment in the table is selected. This is a great visual aid since we need to activate pec motion and tip comp for the material segments. Hover over the top segment. Now set tip compensation to on and set segment pec to full segment. Our pec value will be 50 thousandths of an inch like before. In order to do this, we need to set the minimum pec to 50 thousandths of an inch first, then the nominal pecs to 50 thousandths of an inch. Let's also enter Material Segment 1 into the comment field to help identify it later. Note how we can change the order that these lines will be output in the posted code. Let's make the comment output first. Now hover over the second segment. We don't want tip compensation or pec motion active for this segment, but we do want to enter a comment so we can identify this in the code. Finally, for the third segment, we'll activate tip comp with 50 thousandths of an inch extend depth. We'll also turn on full segment pecking with 50 thousandths of an inch pec distance in all three fields. We'll enter Material Segment 2 as the comment and set it to output first. Let's review the new toolpath in Verify. Notice the pec motion followed by the fast feed through the air. The spindle speed and feed rate changes are displayed in the information panel as well. Most importantly, this toolpath now only takes 12.85 seconds with 5.61 inches of drill point travel distance. This toolpath is over 50% faster than our original with the same exact drilling parameters. Now let's look at the NC code to see how it's formatted. Advanced Drill will only output longhand drill code to make it compatible with as many different machine controls as possible. As we review the code, we see the comments are output at the beginning of each segment. We can see the longhand pec motion at 10 inches per minute, then the fast feed through air at 2000 RPM and 500 inches per minute. The amount of control offered by Advanced Drill and Mastercam 2021 will make it easier than ever to drill the most difficult holes.